Well, thank you everyone for attending. Again, my name is Chad Alley, and I am a MathWorks customer success engineer. And so what that means is I focus on working with faculty and researchers at various universities in the US. And the goal there is to help influence computational thinking more into the curriculum to help students gain the experience they need to be ready uh, for the industry. So today we're going to be talking a little bit about teaching with AI with MATLAB, which kind of touches on similar themes that we've been hearing about earlier today. But before we get there, want to jump into just talking about the environment. So as I'm sure many of you are no strangers to, AI is a very big priority for many companies as we're moving forward. And one of the McKinsey did an independent analysis and forecast that about there will be a $13 trillion increase in value by 2030 to the world economy when it comes to modeling the impact of AI. Now, this sounds great. However, many of these companies also filled out a very similar survey to express their concerns. One of those specific concerns was focusing on the skills of the staff. As you can see, that's one of the major things for companies when it comes to challenges of adopting AI and machine learning into their workflows. And so one of the big things here to take away is that if this is what companies are asking for, we want to make sure that from a curriculum level, we're helping to develop and produce engineers and scientists that have these kinds of skills so that they're ready to take on the challenges of tomorrow. And following that, another question may be, well, how does MathWorks position themselves to better support this kind of system? So Gartner, which is something that I mentioned earlier, basically they have different quadrants that they look at for various developments of technology. One of those areas is data science and machine learning for a magic quadrant, where MathWorks was quoted as being a leader in that area. So, again, this is through 35 plus years of work and development through our product line. And of course, as we continue to move forward, this wouldn't have been possible without our user community to help us improve these products so that those in the field are getting the best out of them. So, we have 35 years in, we don't plan on stopping, and we want to continue working with our users to make sure that we're bringing the best, latest, and greatest stuff to the forefront of technology. And just leading further on into that, this talks more about what customers and key industries that we're focusing on. So again, when we're talking about AI, it's no secret that many of these industries are being touched by AI and will be touched by AI as things begin to progress more in that direction. These are currently some of the industries that MathWorks already supports from various engineering and science levels. And so to add on to their workflows, we want to make sure that we have the support available to help them from an artificial intelligence perspective. Some specific areas where MATLAB is currently being used within AI for some of these specific industries, such as Shell for like deep oil exploration, or Genentech when we're talking about pathology analysis, or even auto driving and self-driving cars and things of that nature. So already we have some of our major customers that are already utilizing our tools for some of these workflows to get further ahead and more efficient in some of the areas that they want to progress in. But again, I think one thing that we want to keep in mind is we've talked about AI. We don't want to look at AI as just a model. We want to look at it as more of a workflow. And that's kind of where MathWorks positions itself with its products, where it focuses mainly on end-to-end workflows rather than just the specific model itself. So for instance, similar to what Esther was mentioning before when we talk about data preparation, that's probably the first most important step, especially when you're training a new model. Right? You need to have millions of images, maybe if not more, to make sure that your model is going to be able to accurately label things and not have bias depending on where you got that specific source of data from. And then we take it to AI modeling, right, where you have your actual network or algorithm that you create in order to do the specific task you want. Following that up with system design. So this is something that Pramod touched on during his opening notes, was about how we can integrate this, right? So we're talking about using AI as in a silo, if you will, when it comes to AI modeling. But let's say we get to an autonomous driving system, right? Now we have to understand how do these things interact with different systems on that vehicle to make sure we have a robust solution that's going to be ultimately safe. And then finally, we talk about deployment. How do we actually get this software or this algorithm out into the hands of those that can use it for the work that they're trying to do? So again, that's kind of where MathWorks positions themselves in this area, is to provide all the tools necessary to develop your end-to-end workflow to be successful in your development. So to touch on data preparation, right? Again, like I think I mentioned before, this is an area where we need to make sure that what's coming in is going to be well understood and qualified before actually being used in a model. Again, the fidelity of your model is only as great as the data that you're going to end up using to help train it, especially when it comes to AI. And so, part of that is making sure that you can test and look at this data and look through it and verify that, things are coming in as you expect or being labeled as you expect. Some of those areas that we have are in MathWorks are called apps, MATLAB apps. Those apps actually help to streamline some of these processes. So as you can see here on the screen, we have two different apps that are showing, one for signal processing and one for a deep learning image tracker. And so both of these are interactive tools that students or faculty can use in order to show and teach these different concepts without having to worry about the code in the background. The beauty behind this, though, is once you've already mastered those concepts using these apps, you can actually generate the code directly from them, reducing the amount of human error you put into the process. And so, maybe a common question is, well, what does AI actually look like in MATLAB, right? Well, for instance, there is a very quick way to perform some specific image processing or image analysis using a webcam, MATLAB, and a pre-trained model within MATLAB using 5 lines of code to start classifying different objects, right? So there's a very easy way to get started that's very well documented, but there's not a very large hurdle to get into being able to start using it from a very simplistic example. So after talking about data, right, now we're talking about the modeling side of things, right? This is typically the fun part that people enjoy, is really developing their model and training it and learning more about how it's supposed to work. Again, this is an area that can also encounter many errors and things like that. And plus, it takes a lot of time to iterate and make sure your model's working correctly. Here, displayed on the screen, you can see 2 different apps that we also have within MATLAB. Again, I mentioned the apps because they're very interactive and they help you to design your network without having to really write any code. So, we have a machine learning classifier app at the bottom, and then a deep network designer app, over in the middle, that allows you to interactively create your networks and models, and then furthermore generate your code much later to see exactly how it was set up. Now, I know obviously we have to look at things from a very holistic standpoint, right? Not all users, or rather, when you're talking about teams and holistic, teams that are focused on a final outcome, not everyone's going to be using the same tools. So we make sure, or the same frameworks rather. So we make sure that MATLAB can actually communicate with all these different frameworks. So that's one of the areas that we like to encourage the use of, is looking at things not from just a tool perspective, but as a workflow, right? If you're using PyTorch or TensorFlow and things like that, you can also utilize MATLAB within that same environment to complete your workflow and use all these different products together for the best of their abilities. So now, again, touching back on what Pramod mentioned, when we get to system design, right? We've done our data processing, we've done our AI modeling, but now we're focused in on how we actually integrate this model into the specific application that we're looking for, right? So again, same concept with automated driving. When we talk about AI for perception of different vehicles in its area of view, how do we make sure that the AI model is actually working with the control system for, let's say, braking or acceleration and things like that, to either slow down the car or move it quicker as it's moving through traffic, and things like that. So there has to be a holistic view of how AI is going to be integrated into a larger system in order for it to be successful. And you can achieve that very well through simulation, through system simulation. So where in a way in which you can reduce the risk that you uh, reduce the risk within your development process, right? Where you can actually test your requirements and make sure that your model's working as you expect. Again, this is part of the whole MathWorks solution when it comes to workflows. And again, finally, we get to the deployment phase, right? You have already created everything, you have it all developed into a system, and now it's time to start shipping it out, whether into enterprise systems or even embedded devices. So again, I mentioned many times, without having to necessarily write your own code, you can use some of the apps that are already built into create your models, generate code from that, and deploy them further to whether it be FPGAs or GPUs, etc. Now, even for classroom demonstrations, we also have opportunities for low-cost hardware, right? Whether students are using Raspberry Pis and a combination of a webcam to employ a deep learning algorithm to recognize different objects, or even utilizing the opportunity of a smartphone directly, a smartphone that many people may have access to, and utilize a pre-trained model from our website to recognize mugs and wallets and things like that, giving students the in-hand capability to get familiar with these systems without having to worry about what's happening at the lower level, at least just yet. And so to talk about that example of our workflow, right, from data processing to AI modeling to system design to deployment, I'd like to talk about a specific example here of a tunnel that was drilled out in Boston. Now, this was done by the Obayashi company. And the idea here was that they have a specific technique for drilling or digging rather, that makes it easy to create a structured tunnel that's safe and stable, and do it in a very efficient manner. Now, some of the issues they ran into with specific tunnel digging is the fact that as they go through, they have to have their geologists check and analyze different areas of the tunnel, different faces, to make sure that certain metrics that they're looking at are in good standing, such as weathering and fractures and things like that. One of the big issues there is the amount of time that takes. It takes many hours just to look at one specific face of that tunnel. On top of that, you're running into an issue where there's a lack of those analysis skills for geologists coming out into the workforce, which makes this a very complicated problem and makes it more costly for these kinds of projects. So what did they do? They in turn created a deep learning algorithm that helped them to analyze a lot of these different areas in the tunnel to make sure that they can do this in a more time efficient manner. Right, so they took a whole bunch of images that they could gather from the different faces of the tunnel, and they only had maybe about 1,000 of them. So typically, with good deep learning networks, you need millions of images to have a very accurate model. So what they did was they used a pre-trained network that was available within MATLAB, and they utilized transfer learning to help basically take that pre-trained model and train it and train it and make it more of a network that's going to support their specific task. And the result of that was that they were able to look at those specific metrics like weathering and fracturing almost to 90% accuracy. And so once they were able to complete these, they they created a solution where they were able to use one of our server products to deploy it to geologists in the field that can use it hands-on and ultimately save time and cost in developing these tunnels. So I think this is a great example of just looking at it from the data collection of the images, utilizing these different AI models that are available, considering the whole system with your custom network, and then finally pushing it to production so that others can use it. But again, these are great skills for the workforce, but it just doesn't start anywhere, right? We have to start earlier on. So when it comes to industry, undergraduate education, and research, MathWorks is right in the center of this to help provide those capabilities early on so that you have that continuous flow of information and experience. And one of the ways we do that is through our self-paced trainings, right? So our trainings are available online for users to go in and learn a little bit about machine learning. They're modular self-paced courses that allow you to go in and go through specific modules, learn about it, and finally build up to a specific project, thus testing your knowledge. One other ways that we want to work with our colleagues and customers within academia is we want to make sure that we are working within our senior design aspect by providing projects. These are specifically in AI, and our goal is to partner with more universities and capstone courses to help you start utilizing some of these projects and getting students more familiar.
Hey, Chad, I'm